Alright, this is Gabriel Galarza, and I'm doing question 6.2.31 for test grade placement for test 3. And this is number 31, where we have to find the volume of this parabola at between 0 and y equals 4 using cross-sections of squares, semicircles, and equilateral triangles. So first we would start off by using squares, and we want to go ahead and start off by saying, since we're revolving it by the y-axis, we're going to go ahead and flip this equation, or this graph, into this. And we are going to go ahead and use square cross-sections. Using square cross-sections, we know that y equals x squared is going to be solved into equaling plus or minus square root of y. So the distance here would be y, and the distance here will be y for each of these squares. Both of them together would equal 2 square root of y. So that would be your length. And since it's a square, every side is the same. So how we would write the area of these squares would be 2 square root of y squared. And then we will be finding the integral of this from 0 to 4. As you can see, 0 to 4. Right? Remember, we are getting the area of this section, or the volume of this section. So once we get here, we're going to go ahead and integrate that. And by integrating that, we're going to go ahead and simplify this into 4y. And this remains the same. And then once we get that, excuse me, I forgot about dy. Once we get that, and once we derive it, we will go ahead and get 2 times y squared. And then we have to go ahead and solve it from 0 to 4. We get 4 squared times 2, which equals 16. And then we go ahead and plug in 0 on this side, and the answer would be 16. Oh, sorry about that. So we're going to put 4 into this, and we get 16, and put 0 in, we get 0, which would give us 16. So 16 would be the volume of this function using square cross-sections. Next, we would have to use, we were asked to find semicircles, or the volume of this with cross-sections of semicircles. So the process is quite similar, except for we would have to use the area of half of a circle, which is pi r squared over 2. Now what we did was we went ahead and looked over here, and instead of this being squares, we went ahead and made this a semicircle. And when we did that, we realized that the radius would be give me a second here.
What's wrong with you, bro?
Okay, sorry about that. But the radius would be square root of y. So, because over here, this would be the radius, which is square root of y. So over here, we went ahead and put pi square root of y over 2.
That's disrespectful.
And this would simplify into being pi over 2, or pi times 2 over y. Integral this, and then here we would go ahead and change or simplify this out into pi over 2 integral y. And then finding the integral of y would be y squared over 2, or excuse me, pi, and then we multiply pi. I'm sorry about that. Let me just start this over. Y squared over 2, multiplying this by pi over 2, which would give you pi y squared over 4. Then you'd go ahead and solve this from 4 to 0, which would give you 4 pi. And that's how you solve it with the cross sections of semicircles. Next, we will go ahead and solve for cross sections of triangles. 4, 0, So we're going to go ahead and assume that these are equilateral triangles here. Correct. And then we're going to go ahead and say, hey, right here, the base would be 2 square root of y. Right? And then we would be looking for the height, because the area of a triangle is half times base times height. So we know our base is 2 square root of y. We would have to find the height. So if we break down the triangle, a half of the base would equal y. And since it's an equilateral triangle, each side is the same, so it would be 2 times square root of y. And we can use the Pythagorean theorem to find this next side. So by using the Pythagorean theorem, we get square root of this, a plus b equals square root of c. And then simplifying this all out, we get y plus b squared equals 4y. We subtract this over, simplify it out, we get b squared 3y, square root the b out to get b equaling square root of 3y. And that's how you get the height. So putting in this formula, we want to integrate it 0 to 4. Over 2 we would have the base, or excuse me, over 2 we would have the base times the height, and then we multiply these two out, or matter of fact we would take the half out just to make it easier for us, because the constants just muddy the water. Y square root of 3y, which would make it 3 square root of y. This would just easily simplify it out to equal y square root of 3. And then we can bring this radical outside here, which would make it square root of 3. Oh, I think I messed up here somewhere. Excuse me. Let me see here. Oh, matter of fact, okay, that's fine. We'll leave that. And then we will find the integral of y, which would be y over 2. And then have to multiply this out. Matter of fact, this is gone. This half is gone. Sorry about that. But we'd go ahead and get this as the integral of y, and then multiply the square root of 3 out. Great.